You have two pieces of paper, yes? You have a white piece with holes punched in it, and you have a colored piece with holes punched in it, yes? Okay. So I'm going to take my two pieces and I'm going to staple them together. One at the very top, one at the very bottom, and then a couple in between. Okay? First thing I want to do is I want to make a cut. Oh, sorry, fold, right? Folds first. So the first thing I want to do is make a fold, and my first fold is almost all the way to the holes, but not quite to the holes. See how I can't really see the holes? And then I want to fold it one more time. This time when I fold it, I want to be able to barely see the edge of the writing. See how it's right to the edge of the writing? You understand that? Yes? Okay. So when I look at my front, I have two folds on my front right here, yes? Okay. Now we have to make a blind cut. We just have to do our best to guess. Some of you have like kind of see-through paper so you can see it. Some of yours, others of you chose darker colors, which is fine. Okay. But when I make my cut, let me just show you. And I'm cutting all the way to the farthest fold. Okay. When I make my cut, all I want to be able to read is standard equations of parabolas. See, I cut a little bit too low because I can almost start seeing the words, but that's fine. I'm not going to worry about that too much. And then I'm going to cut that piece off. Okay? Standard equations of parabola with the vertex at the origin. Oh, we need to take a timeout, don't we? What goes on the back? Our name, right? Because does this count as a foldable? Because I just folded, right? Okay? So I write my name on the back. Back to the front. So I can see where it says standard equations of a parabola with the vertex at the origin, yes? Now, there's another piece in the middle that says standard equation of a parabola with the vertex at HK. I need to just see that, just that as well. And again, I'm cutting to the farthest fold that I just made. So this is where we are so far. Are you all with me? Not yet? Okay, I will wait patiently. Maybe. Just kidding. Remind me I have to tell you something at the end of class. You're not in trouble. Okay. Are we good? Now, on this top flap right here, do you notice underneath there's two sections of stuff? I want to cut so I can only see one section at a time. Yeah, I want to cut right between them. But at this time when I cut, I'm only cutting to that first fold. See, I'm not cutting all the way. I'm not cutting all the way to the same fold as before. I'm only cutting to that first fold. So if you open each fold, you can only see one part at a time, yes? And then when you have that done, I want you to do the same thing on the bottom tab. There's two sections of information on the bottom tab. I want you to cut right in between those. Yes. Anybody have any questions or need any help? Okay, are you done? Okay, we have a little bit of writing to do. So especially if you got a darker piece of paper, you might want a pen or a marker to write on the tab. Okay? Otherwise, pencil's fine. Unless you just want to use another color, that's fine as well. Okay? On the front of this top tab, it is a vertical axis of symmetry. So we're going to write vertical axis of symmetry. And what direction does a parabola open if it has a vertical axis of symmetry? Up or down, right? So I want to draw two parabolas on the front, one that opens up and one that opens down, just to help me remember. You remember the other day when we were talking about parabolas at the very beginning, and I said domain is always all real numbers for all functional parabolas, right? Because we never had talked about parabolas that open left or right, and I said we'll talk about that later. Today is later. Okay. The second tab, notice that it's a horizontal axis of symmetry. So on the front, we're going to write horizontal axis of symmetry. And then we're going to draw two sideways parabolas. Now, what's the difference between the top section and the bottom section? Well, this one has a vertex at the origin, and this one has a vertex at HK, right? So we have two different sections, and the top section of the bottom section is also a vertical axis of symmetry. So up and down. And the bottom one is horizontal axis of symmetry. All right, you with me? So I'm going to put this aside for a second so I can get out a piece of paper for some notes. You ready for some notes? Oh, it's all right. I'll give you a minute to get some paper out. That's fine. I'm going to go and write the first problem that we're going to work on, though. Now, I most definitely did not put my foldable away, did I? Now, it's definitely right here, right beside me, because I need to be able to refer to it in a second. Now, here's the thing about parabolas, okay? Parabolas have so many different pieces and parts of information that you can know about them to be able to write the equation of a parabola, okay? You could know their intercepts, you could know the vertex, you could know where the axis of symmetry is, you could know where the focus is, and where the directrix is. These are two brand new vocabulary words for you, aren't they? Okay? So before we even start on examples, I wrote the examples so you could see a type of problem that you would have, but I want to talk really quickly about this first tab. Okay, I'm going to talk about the vertical axis of symmetry because that's what you're most used to, isn't it? Okay, So this is the graph that's there under that first tab. Okay, this is a parabola that's opening up, right? Do you notice where the focus is in relation to the actual parabola? Like if the focus was hungry, could it, if the parabola is hungry, could it eat the focus? Right? It could, right? What if it's opening down? If the parabola is hungry, could it eat the focus? Yes, so is it okay with you guys if we say that the focus is inside the parabola? Would that make sense? Okay. The focus is a point on the inside of the parabola that helps give the parabola its shape. Okay. What is the directrix? It's a line, right? If the focus is a point, isn't the directrix a line? The directrix is a line that also helps give the parabola its shape. Okay? Any point that I choose on this parabola is equidistant from the focus to the directrix. Any point, that's the same, that's the same. This point, that's the same, that's the same. This point up here, that's the same, that's the same. See what I'm saying? Guys, that's how a parabola is actually formed. Every point that's the same distance from the focus as it is from the directrix. That creates a parabola. Okay? Now, you know that there's other ways the parabolas are formed. We could start with just an equation, couldn't we? And graph from there using our transformation rules. Okay? But when we're talking specifically about focus and directrix, that is how this parabola is made, from its focus and directrix. Okay? Notice the equation, and it gives you another equation for a focus, and it gives you another equation for a directrix. In order to do anything with any of these equations, what do you have to know? Don't you have to know P? P is a distance from the vertex to the directrix, or the vertex to the focus. That distance is P, that distance is P. So sometimes it's easy as it tells you that P is 5, or sometimes it's as easy as you look at the graph and count 1. Oh, P is 1, okay. Or maybe there's a line right here, and so you have to say P is 1, 2. You have to count. Does that make sense? Okay. So let's go over to this. Let me zoom back out a little bit. Let's go to this example right here. Okay. Now, quite a few of you in this room are visual people, including myself. So I'm going to show you how we would do this problem if we graphed it. Are you okay with that? And I'm not talking about like a really focused and specific graph. I'm talking about, here's this. Where's my focus? Well, it's left 1, isn't it? That's my focus. And where's my directrix? Right 1, because it crosses the x-axis at 1. Okay? Well, if this is my focus and this is my directrix, where's my vertex? Right smack in the middle, right? There's my vertex. So if my vertex is at the origin, do you see that we would use one of the top 2 sections? See, vertex is at the origin. Which way does this parabola open? Like that, right? Because it's going to eat the focus, right? It's going to eat the focus for a snack. So what kind of axis of symmetry does this have then? A vertical or a horizontal? So then all we're looking at is this. I don't know about you guys, but if I see this, I'm going to get overwhelmed. Do you see why we made the foldable so that we could just look at this now? It's a little bit better on our eyes and our brain, yes? Okay, so if I'm going to go write the equation for this parabola, I'm going to start right here. I'm going to start at x equals 1 over 4p y squared. Oh, that's part of the equation. If you'll notice on all these equations, there's a 4. Yes, for this one. Is this something you're used to? Y squared? Oh no, right? What is it always? X squared. Well, it's always that because all we've ever done are functional parabolas, parabolas that open up or down. We just decided this one opens left, so does that make sense that it would be backwards? So x equals y squared instead of y equals x squared, right? So the last thing we have to have in order to write the equation is what? P. We have to know what P is. Well, what is P again? The distance from the vertex to the focus or from the vertex to the directrix. It should be the same, right? So how far is it from the vertex to the focus? 1. Yeah. That distance right there is 1. What's that distance right there? Also 1, right? So the value of P is 1. So x equals 1 over 4, because 4 times 1 is 4, y squared. We're almost done. Why are we almost done? True, right? Which way does this open? Specifically, it is horizontal, but specifically it opens left. And if it opens left, it's negative. Good job. Does that make sense? You ready for another example? Okay. What if I don't tell you the focus and the directrix? What if I tell you the focus and the vertex? Are you still okay with that? So I go, for my focus, I go left and right 0, and I go up 6, right? That's my focus, and my vertex is at 0, 0. Which way does this open? It opens up, so does it have a vertical axis of symmetry or horizontal axis of symmetry? Vertical, so I can open the top one, right? Is it the top one or is it this one right here? Top one, specifically because it's at the origin, right? Now, could I use that bottom one where it says the vertex at HK? Absolutely, because HK would just be 0, 0. But this one's a little bit simpler, right? Because it says y equals 1 over 4p x squared. So what do I need to know? I have to know p, right? So what's p again? Distance between focus and the vertex or vertex and the directrix, right? We don't know the directrix this time. We could write it if we wanted. We could figure it out easily, couldn't we? But 1, 2, 3, 4, 5, 6, my p-value is 6. So I would say y equals 1 over, what do you think? Oh, 24? Why 24? 4 times 6, right? X squared. And then I'm done. So what happens if my vertex is not at the origin? Dun, dun, dun. Vertex is at 1, 2, and my directrix is at x equals negative 3. 1, 2, there's my vertex. If it crosses the x-axis at negative 3, it's a vertical line, isn't it? Okay, that's my directrix. X equals negative 3. So first of all, can you tell me which way this opens? How do you know that it opens to the right? It's away from the directrix, isn't it? It's not eating the directrix for a snack, it's eating the focus for a snack. So it has to open away from the directrix. So I know it opens to the right. So what kind of axis of symmetry does it have? Horizontal. And since my vertex is not at the origin, I have to use the bottom one, don't I? Okay. So the bottom one says y, oh, no it doesn't. X equals 1 over 4p y minus k squared plus h. So in order to fill this in, what 3 things do I need to know? P, K, and H. Don't I already know H and K? Isn't that my vertex? How do I figure out what P is? Here's my vertex. I can count, can't I? I can go 1, 2, 3, 4. I just figured out that P was 4 by counting. Do I have enough to be able to write the equation? I do, don't I? X equals 1 over 16 because I have 4 times 4. Y minus 2 squared. Where did we get that? HK is my vertex, so I just looked. And then what's H? 1. HK, right? You okay with that so far? So there's one more type of homework problem that you might see tonight. And it's one of those homework problems that looks harder than it is. Can you just trust me on that one? Okay, here's what they tell you. They tell you that the vertex is at -2, 3. They also tell you that it opens down, like in words. It tells you in words. And they also tell you that it's 5 units from the focus. Why do people think this looks harder? Yeah, there's words, right? There's words. This is algebra. There should be no words. No, there are, right? And that's okay. So I'm going to come over here. -2 up 3. That's all I know as far as the graph, right? But what do I know about it? It opens down. And where's the focus? 1, 2, 3, 4, 5, right? That's my focus. So what did it just tell me that I need to know? P. 1, 2, 3, 4, 5. P is 5. What kind of axis of symmetry does this have? Vertical, right? Because it's opening down. And my vertex is not the origin, so I got to use the top one of the bottom section, right? So I've got y equals 1 over 4p x minus h squared plus k. Okay, all I did was write that down from right here. Okay, do I know everything I need to know? Because here's hk, right? So y equals 1 over 20, and how do you know it's 20? Right, the p that we found a minute ago, 5 times 4, right? And then x, oh, you didn't get tricked, did you? X plus 2. Could you write x minus a -2? Yeah, we would kind of giggle about that, right? Because we don't usually write minus a negative. That's plus, right? So x plus 2 squared, and then plus 3. Any questions about that? Any questions about any of the examples that I did for you today? I can go back over any questions that you have on any of these examples.